We have another circuit, and let's take a look what we can do over here. I'm going to call this voltage source 1, and this one is going to be my voltage source 2. The problem is asking me to find voltage V1. Okay, it doesn't mean that you're supposed to start from solving I2. You can start from solving, let's say, V1 or P4 if you can. So first, please realize that this resistor is connected to two voltage sources. Okay, so this one is negative and this one is positive. So basically the voltage across this resistor is the difference between these two voltages. So I can say that my V1 is equal voltage source 1 minus voltage source 2. Okay, and the current, of course, is going to go from the higher potential to the lower potential. Okay, so we have current which will flow from positive 9 to negative 9. So current is going to go this way. Okay, so this is going to be my I1. So Vs1 is equal negative 9 volts minus 9 volts. So this is equal negative 18 volts. Okay, so this is my voltage across resistor R1. So right now we're supposed to find current I2. Current I2 is the current which will flow through the resistor R2. Okay, and resistor R2 is the part of this network over here, right, which is connected to the ground. So 9 volts is connected directly to this resistor, so current for sure is going to go this way, okay, because it's go from 9 volt to what? To 0 volts, from the higher potential to the lower potential. So now I'm going to find the equivalent resistance for these two resistors. So I have R2 3 is equal R2 times R3 over R2 plus R3. This is equal 4K times 6K over 4K plus 6K. This is equal 4 exponents 3 times 6 exponents 3 equals, divided by, this is going to be 10K. This is equal 2.4 kilo ohms. 2.4 kilo ohms. So now I can redraw the circuit. So this is my resistor R1. This is my voltage source 2. This is my voltage source 1, and I have my resistor R2 3, and this is my resistor R4. As you can see, these two resistors are in series. So what I have to do, just find the equivalent resistance for these two resistors. So R2 3 4 is equal to R3 4 plus R4. R2 3 4 is equal R3 4 is equal 2.4 K plus R4, which is equal 8K. So R2 3 4 is equal 10.4 K kilo ohms, of course. So I found the total resistance, equivalent resistance for these two resistors, right? So again, we can redraw the circuit, and your circuit is going to look like this right now. We have R1, we have voltage source 2, this is my voltage source 1, and this is my R2 3 4. This is ground. So now I can find the current which goes through these resistors. So I have I2 3 4, and please notice that the current I234 is going to be the same current which will go through this resistor, because this current, right, this current is nothing else just the current which will go through all these three resistors, right? But it simply means that this is the current which is going to split, right, into these two resistors, and after that is going to create from these two currents, from current I2 and I3, we are going to make I4. So that's why I say that I234 is going to be equal to I4. So this is equal voltage source 2 over R2, 3, 4. So voltage source 2 is equal 9 volts over R234, which is equal 10.4 kilo ohms. And this is equal 9 divided by 10.4 exponent 3 equals 865.38 micro amps. So this is my I4. This is my I4. Now, if I have I4, right, or I234, I can find I2 using current divider formula. So I can say that I2 is equal I4, we can say, right, I4 times the equivalent resistance for these two, so R23 over R2. Okay, instead of I4 you can also use I234, because this is the same current. So this is equal 865.38 microamps times R23, which is equal 2.4 kilo ohms, over R2, which is equal 4K. So I have I2 equals 865.38 exponent 6 negative times 2.4 exponent 3 divided by 4 exponent 3. Close parenthesis. This is 519 519.22 microamps. Okay, so this is my I2. Next we're supposed to find power at resistor R4. So P4 is equal I4 square times R4. So we have I4 equals this, so we have 865.38 microamps to the second power times R4, which is equal 8 kilo ohms. So this is equal 865.38 exponent 6 negative to the second power times 8 exponent 3 equals 6 milliwatts, approximately 6 milliwatts. So now we've found V1, we've found I2, we've found P4, so we can say that we solved the problem.